At what age do we decrease production on stem cells? That sounds like a good pack-back question. And the thing is that stem cells, there are many types of stem cells. So not all stem cells are the same. Like the stem cells that you find in muscles aren't going to be the same as stem cells in their skin. But this is also an important part of aging. This is why like a lot of anti-aging, or even like degenerate, what we call neurodegenerative diseases like Alzheimer's, or this is why stem cells are another avenue that are being looked at, because what happens is that with cells that when neurons differentiate, they can't reproduce. But what happens in some diseases, and a lot of diseases associated with aging, is that our bodies lose ability, or the wear and tear outpaces our ability to repair. So this is why there's a lot of cool research being done in stem cells. Okay, so loose connective tissue. So what's the difference between loose and dense connective tissue? I know it sounds very vague, but in very generally, loose connective tissue, it depends on the ratio of those solid protein fibers to that gel-like fluid ground substance. So loose connective tissue is going to be less dense and have more of that fluid ground substance and fewer fibers. And that's what we see with this white adipose. You see fibers, but not as much as the dense connective tissue we see over here, where you have all these protein fibers packed. So what you have is a lot of like loose connective tissue, well, you have a lot of cells, but also a lot of space between the cells as well. But in the dense connective tissue, you don't see much space between the fibers. So in general, it depends on the ratio of those fibers to the ground substance. So loose connective tissues are sometimes referred to as like the packing materials of the body. So this is not coincidental that if you look at the white adipose, it kind of looks like styrofoam or packing peanuts, right? So there are three types in adults, so areolar, reticular, and adipose tissue. So areolar tissue is the most common, like you find this in your skin like pretty much everywhere in the connective tissue of your skin. And what's the common thing you see with areolar tissue is that they're a lot of ground substance, very loose fibers, but they're more just to keep like things, generate a very, very loose network that keeps things together, but also doesn't crowd out all these cells. So cells like macrophages, fibrocytes, and other cells that need to migrate or travel between these fibers, because there's a lot of space and ground substance, there's a lot of areas where they can move and mobility. So I like to think of this, if you've ever seen like a building with like a drop ceiling, that they have like the ceiling, when you remove the tiles, it has all this network of vessel or like pipes and wires. I like to think of areolar tissue like that. With areolar tissue, because there is not a lot of solid fibers, you can put a lot of blood vessels through that. You can put a lot of nerves through that. You can have cells moving through this tissue. So areolar tissue is like, or you can think of it as a big, wide open area. So that's what areolar tissue refers to. And common misconception, areolar tissue is not just found in the areola. So it just refers to a more Latin root word meaning space and area. So same root word. So least specialized is an open area. And you have this thick ground substance. Again, it's not just air, but you have all this fluid fluid ground substance between these fibers. So again, even though it looks lighter, it doesn't mean it's just an empty void. So the whole thing is that it kind of holds things as a scaffold in place with minimal solid structures to interfere. Now reticular tissue, this goes back to that root word reticulum or network. So instead of being it's a little more dense than areolar tissue. And what they do is kind of form a mesh. And so reticulum provides support. So I like to think of it like this little 3D jungle gym you might see here. So pretend all these little kids are the cells, and all of these networks here are, have you ever seen that one in Ala Moana where it's like, they have that playground and it has all these network, and it kind of holds all these kids can occupy all these little spaces in there. So those kids are like the little cells in a reticular tissue. So you have this 3D structure, that all this mesh work that helps to hold these cells in place. And you find this in a lot of organs that are, so they're two key words, like when you use in a reticular tissue, stroma refers to the fibers that kind of help to hold the cells in place. But the cells that actually carry out the function of the tissue, like in the liver, we have these cells called hepatocytes that make enzymes and proteins in your blood and also help to detoxify your body from chemicals. These are called parenchyma. So parenchyma are the cells and stroma are all fibers that support it. Adipose we covered.